In this video, we are going to be looking at examples of polynomial long division, polynomial division using synthetic division, and how we can use both techniques of division to apply the factor theorem. We are going to begin with examples of polynomial long division. I've went ahead and set up my division for example 1. I made sure to put the divisor on the outside, and I have the dividend on the inside. We're going to begin the division, and with long division, we are always focusing on the leading terms. So looking at the leading term on the outside, we have a 2x, and the leading term on the inside is a 2x cubed. And we set this up by asking ourselves, what do we have to multiply 2x by in order to get 2x cubed? And what we have to multiply by is x squared. So we put an x squared on top. The x squared gets multiplied by the entire divisor. So now I'm going to take x squared, multiply that by the divisor of 2x minus 5, and we get 2x cubed minus 5x squared after distributing that. What we get when we multiply gets lined up under the dividend. And very crucial step here is that we subtract. So because we are subtracting, we change the sign on the 2x cubed and we change the sign on the 5x squared. The 2x cubes will cancel out. That should always be happening during long division. Combining the negative 11x squared with the positive 5x squared gives us a negative 6x squared, and I'll bring down everything else that was left. And now the process continues where we again are still looking at the same leading term that's on the outside, the 2x cubed, and now the new leading term that's under the division. So now we ask ourselves, or the leading term on the outside is just the 2x. I said 2x cubed, but I just meant 2x. So now we ask ourselves, what do we multiply 2x by in order to get negative 6x squared? And we have to multiply by a negative 3x. That negative 3x goes on top, and that negative 3x gets multiplied by the entire divisor of 2x minus 5. So this is getting multiplied here. I'll distribute this to get a negative 6x squared plus 15x. That gets lined up under our dividend. And we are subtracting, so we change the signs of both of those terms. Becomes a positive 6x squared and a negative 15x. The leading term always cancels out. The positive 13x and the negative 15x come together to make a negative 2x, and I'll bring down the plus 15. The process continues. I now look at the same leading term from the divisor, which is still 2x, and now the new leading term under the dividend, which is a negative 2x, and I ask myself, what do I have to multiply 2x by in order to get a negative 2x? And the answer is negative 1. So I put a negative 1 on top. That negative 1 on top needs to get multiplied by the entire divisor of 2x minus 5. Distributing that leaves us with a negative 2x plus 5. I'll line that up under our dividend. And we subtract, so we change both of these signs. So we get a positive 2x and a negative 5. The 2x terms cancel out. The positive 15 and the negative 5 come together to give us a positive 10. And because the degree of the divisor is 1, and the degree that we now have under the dividend is 0, the degree of the dividend has now dropped down to be less than the degree of the divisor. The process stops. So this 10 here is our remainder. So now we have all of the pieces that we need to write our final answer. Generally speaking, for a division process, the final answer is going to look like the quotient plus the remainder over the divisor. So we started with our dividend of 2x cubed minus 11x squared plus 13x plus 15. And that was divided by our divisor of 2x minus 5. And that is equal to our quotient, which is x squared minus 3x minus 1, plus our remainder. Our remainder is 10, and the remainder stays over the divisor of 2x minus 5. So this here is our answer to this division. To set up example 2, I'm going to put the divisor of x minus 3 on the outside of our division. I will write our dividend on the inside, which is x to the 5th minus 3x to the 4th. Notice that there is no x cubed term, so I'll add in a placeholder of 0x cubed. There's also no x squared term, so I'll add in another placeholder of 0x squared. There is an x term of 12x and a constant term of negative 33. So now we're ready to begin the division, looking at the leading terms. We start by asking ourselves, what do we have to multiply x by in order to get x to the 5th? And the answer is x to the 4th. So we put an x to the 4th on top, and we multiply that x to the 4th by our divisor of x minus 3 in order to get x to the 5th minus 3x to the 4th, which then gets lined up under our dividend. And because we are subtracting, we then change the signs of both of these terms. So this becomes a negative x to the 5th and a positive 3x to the 4th. So these cancel out. We have zeros here in our next term, so we don't really necessarily have to bring those zeros down. The next thing that we would bring down would be the 12x minus 33. Again, we're still looking at leading terms. So we ask ourselves, what do we have to multiply x by, that's the leading term from the divisor, in order to get 12x, which is the new leading term under the dividend? And the answer is 12. So we put a plus 12 on top, and that 12 gets multiplied by the divisor of x minus 3 to give us a 12x minus 36. That 12x minus 36 gets lined up under the dividend, and because we are subtracting, we change both of their signs to cancel out that 12x, and the negative 33 and the positive 36 come together to make a positive 3, which is our remainder. So now we are ready to write our final answer, that this division of x to the 5th minus 3x to the 4th plus 12x minus 33 divided by x minus 3 is equal to the quotient of x to the 4th plus 12 plus the remainder of 3, which stays over the divisor of x minus 3. We start off by putting our divisor of x squared minus 3x plus 4 on the outside of our division and our dividend of 2x cubed plus 2x squared minus 16x plus 32 on the inside. We begin by looking at leading terms, which are x squared and 2x cubed. We ask ourselves, what does x squared need to be multiplied by in order to get 2x cubed? And the answer is 2x. That 2x goes on top, and that 2x then gets multiplied by the entire divisor. Distributing the 2x to all three of those terms gives 2x cubed minus 6x squared plus 8x. That gets lined up under our dividend, and it gets subtracted from the dividend. And because we are subtracting, we have to distribute the subtraction to all three of the terms, which is going to change the sign of all three of the terms. The leading term should always cancel out. We're left with an 8x squared minus 24x, and the process continues with us looking at leading terms. We're now asking ourselves, what does x squared have to be multiplied by in order to get 8x squared? And the answer is 8. So we will add 8 on top in our quotient, and then we will take that 8 and multiply it by our divisor. Distributing that 8 to all three terms in the divisor gives us 8x squared minus 24x plus 32. I'm going to also bring down this plus 32 right here that I did not bring down earlier. I will line up that 8x squared minus 24x plus 32 under our dividend, and because we are subtracting, all three of these terms change signs. In this case, everything cancels out and leaves us with a remainder of 0. So our final answer is that the division of 2x cubed plus 2x squared minus 16x plus 32 and x squared minus 3x plus 4 is equal to the quotient of 2x plus 8 and no remainder. So I don't have to do plus 0 over x squared minus 3x plus 4 because that's just 0 and it does not change the answer. But do notice that when the remainder is 0 and I don't have that little extra part there, I could take this equation, our result from the division, and if I had multiplied both sides of this equation by this denominator, it would cancel out there, and it would show up right here. Simplifying this, we can see that 2x cubed plus 2x squared minus 16x plus 32 is equal to 2x plus 8 multiplied by x squared minus 3x plus 4. So the moral of the story is that when the remainder is equal to 0, that we can then see that the divisor is a factor of the dividend. Because this divisor right there is sitting as a factor of this dividend here. And we will see that observation come up again when we look in more detail at the factor theorems. Most people are not a particularly big fan of long division. It's easy to make a mistake. You have to pay attention to your signs, and you also have to make sure that you're multiplying correctly. Another alternative to polynomial long division is synthetic division. However, synthetic division can only be done when you are dividing by a binomial of the form x minus c. It could also be x plus c if c is a negative number, but you need to be dividing by something that is linear. So now we're going to go through this example here using synthetic division. Keep in mind, if we go back to the first page, the first example could be done using synthetic division. Well, it could be done, but this is not of the form x minus c because you have that 2 in front of it. So you kind of have to be a little careful if you choose to do synthetic division with that 2 in front of the x. But you could definitely do synthetic division in example 2 with that x minus 3. In example 3, you could not use synthetic division. And the reason that you absolutely could not use synthetic division in example 3 is because you are dividing by something that is quadratic. It does not have an exponent of 1. To set up synthetic division, the first step is that you write the value of c in a box. To figure out what c is, you can always take whatever you are dividing by and set it equal to 0 and solve for x. And you can see that c is equal to 8. So I'm going to take 8 and I'm going to line it up in a box. Then I'm going to line up the coefficients of the dividend right next to the box. The dividend is right here, and the coefficients of that is that I can see in front of x cubed is a 1, in front of x squared is a negative 13, in front of x is a 46, and in front of the term that has no x, x to the 0, is a negative 49. I'm going to skip a line and draw a horizontal line below the list of coefficients. I'm going to bring down the first number, which is 1. Anything that crosses that line gets multiplied by the 8 that's in the box. 1 times 8 is 8. And we add here. So we have negative 13 plus 8, which gives us a negative 5. The negative 5 has crossed the line, so it gets multiplied by the 8 in the box to give us a negative 40. And we add. 46 and a negative 40 come together to give us a positive 6. We multiply. 8 times 6 is 48. We add negative 49 and a positive 48, making negative 1. So now that we have finished the division, we are ready to write our quotient and our remainder. The quotient comes from all of the terms except the last one. The remainder comes from the last term that you got in your division. So what's underlined in green gives us the coefficients to our quotient. Because the dividend started with an exponent of 3, and we divided by something linear, the quotient will now drop down to an exponent of 2. So we now have 1x squared minus 5x plus 6 with a remainder of negative 1. So our final answer is that the division of x cubed minus 13x squared plus 46x minus 49 divided by x minus 8 is equal to the quotient of x squared minus 5x plus 6 and a remainder of negative 1 that stays over the divisor of x minus 8. To set up example 4 using synthetic division, I will first set the divisor equal to 0 to see that the number that goes into the box is 3. I will put 3 in the box and line up the coefficients of my dividend. In front of x to the 5th, there is a 1. In front of x to the 4th, there is a negative 3. There is no number in front of x cubed, nor is there any number in front of x squared. In front of x, there is a 12, and the constant term is a negative 33. I've skipped a line. I've put my plus sign. We begin by bringing down our first coefficient to get 1. 1 multiplied by 3 is 3. Add to get 0. Multiply. 0 times 3 is 0. Add to get 0. Multiply. 0 times 3 is 0. Add to get 0. Multiply. 0 times 3 is 0. Add to get 12. Multiply. 12 times 3 is 36. Add to get 3. The dividend started with an exponent of 5. That was the degree of the dividend. So our quotient is going to drop down to an exponent of 4. I look at all of the coefficients here except for the last one to get the quotient. And that last number there is going to be giving us the remainder. So now I'm ready to write the quotient, starting with an 1x to the 4th. So the 1 is coming from this one, and the x to the 4th is because I need to take away 1 from the 5 that we started with. There is no x to the 3rd term, there is no x squared term, and there was no x term. The constant term there is 12, and then we have a remainder of 3, which stays over our divisor of x minus 3. We don't have to write this with all the zeros. We could simplify this to x to the 4th plus 12 plus 3 divided by x minus 3. Please notice that example 4 is the exact same example as example 2, and we are getting the exact same answer of x to the 4th plus 12 plus 3 divided by x minus 3. In our last example of synthetic division, I will begin by setting the x plus 10 of the divisor equal to 0 to get a negative 10. That negative 10 is going to go into our box, and I will then line up the coefficients of my dividend, starting with x to the 3rd. I can see that there's a 3 in front of that. X squared, be careful, these are written out of order, has a 25 in front of it. The x term has a negative 48 in front of it, and then the term that has no x has a 20. Skip a line, put a plus sign. Bringing the 3 down gives me a negative 30. Adding gives me a negative 5. Multiplying gives me a positive 50. Negative 5 times negative 10 was a positive 50. Add that positive 50 to a negative 48, giving us a positive 2. Multiplying that positive 2 by the negative 10 gives us a negative 20, and then adding gives us a remainder of 0. So now we can see that the quotient of 3x cubed minus 48x plus 25x squared plus 20 divided by x plus 10 is equal to 3x squared. And I'm starting with x squared because this started with x to the 3rd, so I drop down to x squared and just decrease my exponents. So we have 3x squared minus 5x plus 2, and there was no remainder, and so I do not need to do the plus 0 over x plus 10. And again, notice that when the remainder is equal to 0, and we do not have to write this, then we could take this equation and quickly multiply both sides by the divisor to cancel it out on the left-hand side and be left with a much simpler equation that 3x cubed minus 48x plus 25x squared plus 20 is equal to the product of 3x squared minus 5x plus 2 multiplied by x plus 10. So we can once again see that when the remainder is equal to 0, that the divisor of x plus 10 is a factor of the dividend. And that example brings us to the factor theorem, which states that if we have a polynomial, if f of c is equal to 0, which means that c is a 0 of that polynomial, f of c being equal to 0 would also mean that the point c0 is an x-intercept, then x minus c must be a factor of the polynomial. We also have the reverse of that statement, that if x minus c is a factor of the polynomial, then f of c is equal to 0. So in example 6, we're being asked to use the factor theorem to determine if x plus 4 is a factor of x to the cubed, x to the third plus 3x squared minus 10x minus 24. So how we're going to do this using the factor theorem is the factor theorem says that if x plus 4 is a factor, then when we plug in the c value that corresponds to that, we would get 0. So in this case, let's first realize that x plus 4 is the same thing as x minus negative 4. So in this case, c is equal to a negative 4. So I'm going to plug in negative 4 into this polynomial. F of negative 4 would be negative 4 cubed, and we do need to use parentheses when we raise a negative number to an exponent, plus 3 times negative 4 squared minus 10 times negative 4 minus 24. If we punch all of this into the calculator, we will see that we do in fact get out 0. And so because we are getting 0 out, we can then conclude that x plus 4 is a factor of x cubed plus 3x squared minus 10x minus 24. And the idea behind this is that we've just seen that when we plug negative 4 into this polynomial that we get out 0. That means that when you try to factor this polynomial, it must be that x plus 4 is one of those factors. That does mean that there is some factor here that we do not know. I'll write this as a missing quadratic factor. And I know that this missing factor is quadratic. All quadratic means is that it has degree 2. I know it has to have degree 2 because I have a degree 1 right there. And I know that they should come together to give me a degree 3. So this would have to have degree 2 in order for these to multiply together to give us x to the third. But if you look at the right-hand side of this, automatically when you plug in negative 4, you're going to be getting 0 out because of that x plus 4 factor. And that is the essence of the factor theorem. Example 7 is asking us to write a polynomial of degree 3 that has the zeros of 2, of multiplicity 2, and negative 5. So to write our polynomial, I'll call it f of x. If it has a 0 of 2, that must mean that x minus 2 is a factor. That is very important, that whole concept. The idea that if you have a 0 of c, it implies that x minus c is a factor of your polynomial. That's perhaps one of the most important things in this lesson. So we have the 0 of 2, but they tell us that they want it to have multiplicity 2, so I'll put a little squared right there. And then we also have a 0 of negative 5. Well, if negative 5 is a 0, then x plus 5 must be a factor. The 0 and the factor always have opposite signs. And the last thing I will do is multiply all of this out. This is from foiling. Let's make sure we are foiling this. Foil out this x minus 2, multiply that by itself. So when you take x minus 2 and multiply it by x minus 2, you'll be left with x squared minus 4x plus 4 after combining like terms, and that has to be multiplied by this x plus 5. I'm going to go ahead and use the distributive property to go ahead and finish simplifying this to get our final answer of x to the third plus x squared minus 16x plus 20. Keep in mind that this is not the only answer. Yes, this polynomial does have degree 3, and I know that we guarantee that it has a 0 of 2 with multiplicity 2, and it also has a 0 of negative 5. But even if I were to take this polynomial and multiply it by a 6 in the front, it still has a 0 of 2 with multiplicity 2, and it still has a 0 of -5. In fact, it doesn't matter what number we put in front of the polynomial. As long as we put a real number in front, the zeros stay the same. So these coefficients in front of the polynomial do not affect the zeros or their multiplicities, because it would just put a -7 here, a -7 there, a -7 there, and I would need to put parentheses around this, and I could distribute that -7 in. And the polynomial would still have a 0 of 2 with multiplicity 2, and it would also still have a 0 of -5.